I'm going to demonstrate how to run and make changes to a running Sirepo application. And then just briefly before I start on that, I wanted to point out that the Sirepo wiki page is available off of GitHub. So if you come to the main RadiaSoft Sirepo and come to wiki, there is a wiki document available for how to set up a developer. From this point on, I'm going to assume we have a developer environment. So I've got a window here. And actually, let me stop for a second. If Oleg or anyone else has a question during this, feel free to break in. Don't hold it to the end, just so we so I don't leave anybody or confuse anybody.
Thank you.
So here, actually, I'll exit all the way out of my VM. So here I am on my Mac, and in this case, I made a directory following the development steps here and created it. So I can now SSH into my VM. And so here I am. I'm in Home Vagrant, and it is Fedora VM. It's relatively current, I think. And in my case, I do all my development out of Emacs. So the first thing I always do is start Emacs and then start a shell. But everyone likes their own development environment.
A question. Could you use some editor on Linux and then simply whenever you have updated source, send it to this Fedora environment, like using your Macintosh friendly stuff, for example?
Right. So some people develop with the source shared between the VM and the host. And that's one way to do it. Mike does that. I know Maxime does that. I prefer to do all my development within the VM. So I run an editor within the VM called Emacs. Some people run Vim, for example.
All right, so, but the answer is it is possible. If necessary.
It is possible, yeah. So if you have your editor, your favorite editor on your Windows machine, you can continue to use it. And when you save in that, it'll actually be updating the files in the VM at the same time. Okay, so here I am, and I'm going to go into the source RadiaSoft directory. And if you installed the VM using the developer instructions here, this should already be present. If it's not, you can get it from GitHub. One step that might be required if your VM is rather old and your source isn't up to date, you can do a git pull. Mine's all up to date. If there's a case where the development environment might be really old, like in Oleg's case, you might try pip install -e, I believe it's dot. And that goes through and makes sure all the dependencies are up to date. And I'll just show that again. So that's this magical command.
Okay, pip install pip install -e dot.
Yeah, and that may or may not help. Your environment might be rather old, and it might be easier to just do a new VM install. Okay, so here I've got the VM, and I can start a HTTP server by running Sirepo, which is the name of a program. And just running Sirepo by itself shows there's several different things. For example, if there's a Sirepo SRW, which would run SRW simulation. So here I'm just going to say Sirepo service. And then it, in turn, says there's a couple different services I can run. The one I'm interested in is the developer HTTP. Okay, so it's running. It says it's running on port 8000.
And you have always in the Sirepo root directory on when you do this?
Right, right. So I am in RadiaSoft Sirepo. Okay, so I ran this, my VM is named V4. So depending on how you have it configured, you can go to maybe I have to do this, V4. So I can go to v4.radia.run. That's a little bit confusing because the name of my VM is V4. If you were in V, following these instructions, it would be v.radia.run. Under the covers, see, it's really just resolving to a static IP address. So I could also come into 10.10.10.40 in my case. If it was let's see, what would I say? v.radia.run, I would just say 10.10. I don't have that running at the moment. But since this is my fourth VM, it gets assigned to this 40 IP address. Confusing, but it's in the development. Here it describes a little bit about what the host name is going to be. Okay, so here I've got the VM running. I can confirm over here that there were requests made. And in my case, I'm actually going to look first at the Hello World application just to show it to you, and then we'll look at the code for it. So I'm going to go to myapp, which is the Hello World application. And you've got a list of simulations, maybe some directories if you've created some. And you've got an example, which is shown in green, or sorry, in blue. And any user-owned simulations are shown in green. So in this case, I could say, I'm going to open a new copy of this Scooby-Doo one. And this is just a very simple app that has one form and one report and one tab. So there's really bare bones, but you can come in here, and if I change something here, like I change the weight, hit save, what happens here is it goes to the server, generates an input file, then runs a external program. In many cases, that would be like running SRW or running Elegant or running any number of programs with an input file. When it completes, then the client then requests any of the output from it. In this case, it's a simple plot showing two lines, really, height and weight. And then all the other things that are part of normal Sirepo are here, so I could export it. I could look at the Python source, and we can do that quick. In this case, this is the Python source, and it's really not very exciting, but you can see that it generated some values, it wrote them to a file, and then it ran an external program that takes a YML file and produces a CSV output file. So really it's just showing that this is the generated code that Sirepo made for this particular simulation. In SRW, it would generate a large execution Python file, which it would then run and then interpret the data files created to then return a plot data for the client. Okay, so now I'm going to look at what is the basic part of this application. And really, almost everything in Sirepo is driven off of what we call a schema file. And that's the file that determines what are the models. In this case, there's a dog model. What are the fields? And what are the data types on the fields? So in this case, there's a dog model. There, it has a breed, which is a string, and height and weight, which are float values. And so we can go and look. And so here I am in my editor. So I'm going to go into, actually, let me show you this as well. This is actually the Sirepo tree. So I'll close it up for a moment. So this is the root Sirepo. And then within that, there's another Sirepo directory which has all the Python sources, as well as data files and things like that. So here's Sirepo. It's got various things for, you can see there's a blue sky thing in there. There's some OAuth, cookie handling, various programs that you generally don't have to worry about. Within there, there's a package data. And these are the items that get distributed potentially to the client. So there's static and JSON, JavaScript. So in this case, here's a bunch of JavaScript. There's Sirepo common files. So like this one would, components are various UI components. Lattice would be for constructing a lattice. Beamline contains code for like the SRW beamline page and the shadow beamline page. And then also within here you see specific applications. So here's the shadow JavaScript, which controls all the JavaScript, the business logic basically for shadow on the client, or the SRW one. And for our case, there's the myapp, which is the hello world one. We'll look at that in a moment. But more important is the schema. And so each app has its own schema. SRW has a schema here. Myapp has its own schema, and I'll open it in the browser or in the editor over here. So it's in package data. Let's see. Okay, so here's the schema file for the Hello World app. And just to refresh, we've got a single model called dog that has a couple attributes. And within here, we see here is a section called model, which contains all the model definitions for the application. So in this case, I've got a model named dog. It's got a breed, a gender, height, and weight. Additionally, it's got the data type. So breed is a string, height is a float, and weight is a float as well. Gender has the type gender, which is actually defined above as an enum. So anytime you've got an enumerated type, it would be defined here. And in this case, it shows up on the drill down page for the editor, so I could change it between male and female and save it, and it would do something. So let's look really quickly at a more complicated one. Let's look at SRW schema and look at the model section. So here in SRW, we've got something familiar. We've got an aperture model, and it's got some various attributes: the position, its shape, the size and offset of the aperture. And within this, you can see we've got the name, the label that appears in the user interface, the data type. I have to remember what one is. That's the default value. This would be any help text, and this value actually is a lower bound for float. So in this case, it can't be 0, so it's some very small number. And yeah, that's enough about SRW. We'll go back to my app. So we've got a model that has all the items that show up in the user interface. So within my code, I never have to say breed anywhere or weight in pounds. All that information comes out of the schema itself. So if I wanted to say change height, change the schema, in this case, I have to restart the web server. Changing the schema requires restarting the web server because it caches all of it. If I was making JavaScript changes or other UI changes, a lot of times you don't need to reload the web server. But here I can see I've got new height in here. And then also new height shows up here. So you never have to worry about labels or placement or fields within your user interface code. All of it comes out of the schema. So let's look at the schema again. So here we've got the view section, which defines how are the labels laid out. Are they laid out just as a column, or is it laid out, let's say, with tabs, or maybe there's multi-columns within the user interface? That's all defined here. And so most models will have a corresponding view. So here I've got a dog model. Here I've got a dog view. It's got a title, which shows up here. It's got basic, which are the fields which are shown on the main panel. So here I'm showing breed, weight, and height, and that's the fields shown here. And if it has an advanced editor, that's what shows up with the pencil. So if I come to here, I see I've got different fields, maybe laid out differently. And basically that lets you have common fields here, and then if there's advanced fields that aren't as common, you can hide them away. Okay, so that's that. So this is a very simple view. Let's look at a more complicated view, say within SRW. So let's see, I'll go to V4. So let's look at this particular view, for example. So this is the single electron spectrum report in SRW. And let's see, first I'll find the name of it. And I have to remember what this is called. Okay, and this particular model, I believe, is called the intensity report. It's got a couple of different fields, as you can see here. So distance from source, initial energy, and then here you can see those fields are arranged here with some other ones off to the side in a second tab. So here's the model for it. And again, you can see the labels, and you can see default values and field types and so on. So we're going to go down to look at the view for this. Okay, so here's the view. We've got a title, and basic is empty, and that is because if we're looking at this report, there's no fields to edit here. And in fact, all reports don't have any basic editors. They're all put within the advanced section. So here's advanced. And the way we define tabs is with this sort of arrangement where you'll have the name of the tab and all the fields within it. So here we've got a tab called main. Here we've got a tab called accuracy. And then within that tab, you can see the field list here. And then you get to this interesting field, which is actually shown as columns. So in this case, we've got horizontal and vertical, and those are showing up here. And often in editors, we'll have horizontal and vertical columns that will include many fields. In this case, it's just position. And then the accuracy tab has 3 fields. 2 of them are being shown, most likely because there's some JavaScript business logic which is hiding it. So if we set it to manual or auto wiggler, the fields are displayed differently. So if I'm on manual, I see probably precision. Actually, I'm not sure what I see. Magnetic field, precision, method. I see. So there's precision. So if I've selected undulator, I see the precision field. If I've selected manual, I see the method field, which must be named let's look for step size. I don't know actually how step size is showing up here, but there's business logic basically triggered on what I'm showing here. That's kind of interesting. Relative. Huh. Okay, so that's a simple editor, or actually a more complex one really, because it's got tabs, it's got additional columns, and so just to emphasize, almost all the layout of the pages comes from the schema itself, at least as far as each of the individual panels are concerned. So now I'll turn back to the Hello World application and sort of show, so how is it that this page shows this model and this report? And so we'll look a little bit deeper at the application. Actually, I want to show an image at this point. This one, but this one. Okay, so this is kind of showing, again, how things get laid out. So here is just showing we've got the schema file, which is being interpreted by Sirepo JavaScript code. And it will lay out this particular thing using the schema. And then within the SRW specific business logic, it handles button clicks, rearranging the page depending on what the model data is. So like in this case, in the SRW.js, there'll be maybe some special code to hide or show fields, depending on if I've clicked on one of these particular fields. So that's sort of what's going on with the JavaScript reading the JSON file and then determining how to lay out the pages. Okay, so let's look at Hello World application. There's a Hello World application wiki page. And again, we talked about the schema. So here's the schema, which we've talked about. It's got all the metadata for the application. Here's the default data that gets created when I say file new. So let's do that within the app. So if I'm in the app and I say new simulation and I call it my simulation and I save it, it opens it here. But the question is, what is the simulation data? So let's come back here. And I don't want to look at Python source. I actually want to look at the JSON file it used, and I'm not sure if we have a way of looking at that directly.
Isn't that in the self-extracting?
Yeah. So I'll open the zip. Okay, and then it contained a file called sirepo.data, and let's look at the raw data. So this is basically the Sirepo database is really these individual JSON files describing the simulation. And luckily for this app, it's really very simple. This is really the state of the app, is this particular model's settings. And then the rest of it is things you don't necessarily have to worry about, like what folder it's in, or, well, there's the name of the simulation. But all of there's no like SQL database. At the end of the day, it's really just a file that's a JSON file kept in a directory. And actually, so if you have a question of where is this on the server, actually, it's actually this simulation ID, which shows up here. And then also it shows up in the URL. So here you notice I'm on in myapp source, and then there's this sort of gobbledygook ID, and that really is the ID of the actual file. That's how Sirepo on the server knows I'm dealing with this particular JSON file. And let's look at this actually on the server once. Okay, so here I am in my, actually let's make that full screen. I'm in my terminal window. I've gone to my Sirepo directory, and within that there's a run directory. Go in there, and that's actually where, actually it's got one directory in it, where the server keeps its state. On production it's very similar. There'll be a user directory which is configured that runs on the server. And in development mode, it just exists within the Sirepo tree. So here I'll look at user. If you had multiple people connect, so like let's say I brought up a new web browser. Okay, so I brought up the Chrome web browser, which is going to have different cookies. So it'll actually have a different session, and I connect to it. There you can see it's given me all of these things that you get as a new user, saying welcome, click on things, and uses cookies. But the point I'm trying to make here is, if I look now here, there's now 2 users. And then on a production system, there'll be many users, and this includes anonymous and people who've authenticated with GitHub. Okay, so back to the question of where does this data live? I'm going to, within this directory, I'm going to look for this ID that I got from the URL, or you can also get it from the simulation data file. And you can see it's user this, and there's myapp, which is the Hello World application. And then there is a directory with that name. And so if I go in there, let's see, it's called. So if I look within this directory, I'll see a Sirepo data file, which is exactly the same as the one we were looking at from the zip file. And then also any of the reports that have been run, you'll see a directory here. So what Sirepo will do is, when I go to execute a simulation, it creates a directory, subdirectory, based on the report name, gathers all the files it needs, generates the code it needs, and then executes it within that directory. So if we look in the height weight report directory, we'll see it has an input file, which is JSON coming in, and it generates a parameters Python file, which then it'll run. It outputs all that to run log, and in this case, it creates this file and parses it into that. So we can just look quick what this sample app does. There's the Python source, and it runs this program actually Rob made called Hundli, which means dog, I guess, in Swiss German maybe. And really it's just a simple file that takes YML and creates a CSV file from it. Mm-hmm. So here it's created this output file. So within my application then, when a request is made for that report, it would come in, find this particular data file, and arrange it in such a way that the client accepts it. Basically, it's a JSON file with a bunch of parameters. And we can look at that in a moment.
So Hundley is an executable that does
Right.
the calculation?
Yes,
No.
exactly. So it's sort of like a placeholder. So like if we were running a compiled program like Elegant, you would run Elegant. It would generate an Elegant ELE file and an Elegant lattice file, and then actually physically run the Elegant program against that file within this directory.
So, but can you confirm again that this line, I mean, this three strings define the program and then the file to load?
Right. So, and this is kind of a toy program. Let's look at the SRW example instead. So let me go to this, and so I know the simulation ID, and then that should exist here, and it does. And if I look here, I've got my Sirepo data file, which I can look at just in the editor. And here you'll see it's got quite a bit of data in it. It's got all the report settings. It's got an undulator and a tabulated undulator. Probably has an electron beam. Right, so here you see all the things that you're familiar with.
Mm-hmm.
And then within this directory, you can see for each of those reports, it came in and generated a file. So let's just look at Flux report, for example. So it generated parameters.py and then executed it. There's py, and it's your standard templated auto-generated code, and it ran that file, which produced this data file.
Mm-hmm.
And then basically it said, once it was done, it said, I'm done. And then the next time the client came asking, can you show me the Flux report? It would say, yes, here's the data. It's done running and all of that. And we can look at that, but I'm actually digressing a little bit. I wanted to pull back for a sec just to say, how did this page get laid out the way it is? Why is the dog report on the left? Why is the physical characteristics report on the right?
Yeah.
So let's look in package. So first to look at the schema again. So we've got another item in the schema. There's two interesting things I didn't discuss. One is the name of the JavaScript file for the business logic for this particular application. In this case, we almost always name it based on the app. So like srw.js has all the business logic for SRW. In this case, myapp.js has the business logic, which there really is none. There's no real extra logic here. Also within here is the tabs, basically, that appear in the Sirepo app. In this case, there's just the source tab. If we would look at SRW, we would see we've got a source tab and we've got a beamline tab. So the source tab is saying I'm using this particular item, which is defined in my myapp, and I'm using a template to lay out the page called myapp source. And this is where really this isn't very specific to Sirepo. It's really the framework we used called Angularjs. So if I would So we use this particular library, which is very nice for creating client-side applications. So this is called Angularjs, and it's basically just a nice little framework. You can see here it's got some examples. And really, it's very template driven. So I can look at, here I've got a couple templates defined and so on. So we'll look quickly at the template that lays out this particular page, and it should be quite simple. And it's in the static HTML myapp. So if I'm in static, I go back directory to HTML and then myapp source. And here we see the way the page is laid out. There's another technology we use called Bootstrap, which is software developed by Twitter, actually, to render pages in a really nice fashion. So the blue, all of the sort of HTML-like layout of this page is done by Bootstrap. And it does nice things where if I'm on a smaller device like a tablet, it lays out the page differently than if I'm on a big page or on a very large page. You can define it. And then that comes from Bootstrap is web page, and we are using version 3 at the moment. We're not on version 4 yet. And it has some really nice descriptions on how to lay out pages and nice things with forms. So here you see a form here, inline forms, and so on. So we use all of the styling basically is from this Bootstrap library. And it's really, both Angularjs and Bootstrap are very heavily used by lots of other websites.
Sometimes it makes a kind of a little bit not very, alignment which is a bit counterintuitive, I would say. And there is probably a reason for this, because something is a little bit larger than standard size and it creates another column and things like that.
Yeah, yes. And actually there have been alignment issues, and that's actually been faults of ourselves rather than actually the code. So recently I fixed an alignment problem when this page would get really small. There we go. It used to be that it wouldn't align very well. And actually, if I bring the same one up on beta, it probably still may have the same problem. Let's look.
Yeah, but I mean also sometimes the intensity reports are created in a kind of live in empty space, I would say. If you scroll down.
Yeah. Right. So there is issues with this gap, for example.
Yeah.
Yes, and that's again our fault. It's something we need to. Well, I guess it's not necessarily our fault, but it's not something you get for free out of Bootstrap. But it's definitely a solution. I was thinking of this particular problem where if the page wasn't rendering correctly, if for example this thing wrapped and then you have these things misaligned. But we sort of fix these problems as they come. So that particular one's been fixed over here. You can see these guys stay aligned. And there is a ticket out for that problem with the extra space appearing.
Okay, that's just
yeah. Okay, so here's the HTML that lays out the dog panel, and really there's a container, and this is just standard Bootstrap saying there's a row and a column which says I want to be 6 wide on a medium display.
Was it created automatically, or
no.
You can?
Right. So all this is hand edited.
Okay.
And if we would look
can you make some small change so it will reflect the layout?
Sure. So let's change the layout. So, well, really, you can do anything. So I could add let me get out of web mode just a moment. I could add so that text should appear. Not formatted very well, but there it is. So I can make changes to this and within the HTML, it will get another.
Yes, but imagine that can you create another input field in this HTML?
Sure. Well, you don't. Yeah. So what you would do is let's say we wanted to add a field to this. We could come to the schema, and then let's say we're going to add a new field like I don't know, is I don't know, what's a furry? Fur length. And we'll call it fur length, and we'll say it's in centimeters, and it has a default value of centimeters.
But for this thing, Paul, you don't use HTML. You use a special kind of mechanism through JS,
right. So it's within the schema. That way I don't actually have to deal with the HTML to lay out these fields, which can get.
And in this HTML file, they even don't show up as individual entities.
Correct. Right. And actually, the only way to see them is to actually look at them with a web browser inspector. So here I can look, and I can see here's a
some input.
Yeah, here's a div that has a label in it, but really all of that is magically put together when the Angular application is running.
Are you allowed to do some more complicated logic on the default values? Like, could you, if some other field is this, then you use this for the default value, or? Sure.
So I'll get to that in a moment, and that would be within the application-specific JavaScript file. So let's just add fur length, and here I'm going to add it to the do as well, so it shows up. Thing to be aware of is editing JSON can be frustrating because it is very picky. Its parser is extremely picky. So, if, for example, I had a trailing comma there, it would not parse correctly.
You have JSON mode in your Emacs?
Yeah, I actually don't. I use web mode, which I think is just rendering it as JavaScript, which is close, but it doesn't. I bet there's a way it could flag it for me to tell me there was an error. And since I changed the schema, I'm going to restart the service. And we'll just see. All right, so there's our new field. And it didn't get the default. And actually, the reason it didn't get the default is it didn't actually fix up the data. Most apps do this by default, but this one doesn't. So I'm going to ignore that for now. Often on apps, if you just add the field with the default data, it'll show up with the default data attached, but this is sort of a fail on my part, and it didn't. But I can come in here and edit this, and I can say he's got 4 centimeters of fur, and then it should remember that. And I'm just actually reloading the page. Yeah, and it remembered that the 4 has been safely saved away. And so that's everything really comes out of this. There's generally no fields on a page that aren't directly in the schema.
There was a case recently when Maxim Rakitin was trying to repair to tweak some input box from plain inputs in some crystal kind of input data to some sort of set of choices, like down menu, and he was suffering quite a bit. I don't know. I mean, can you maybe talk a little bit about these things? How, I mean, besides this simple input boxes, what are other options you have, and so on?
So we could do an enum field, and I think in Maxim's case, the pain came actually because it was converting a float value field that had existing data
Yeah, there was some automatic conversion that depending on the type of data, it was using different.
Right. And so it's much easier to, let's say, add a new field than it is to, say, convert, say, a float to an enum. But I'll show you how to add an enum for the myapp. So let's add a new field, and we'll come up to here, and we'll call it disposition. I don't know how to spell that, disposition. And we're going to name it, give it a type of dog, disposition, and we would give it a default value of friendly. And then here's where we have our selection list. So I'm going to call it dog disposition and give it the value on the left is the internal version. So like in SRW, often things would be something like 1 and friendly. And the one on the right is the label, and angry. We'll give it 3. Then we will add disposition to our view as well. And restart. And so it didn't get the default value, as I said before, but most apps generally would. And I can say it's friendly or it's submissive. And if I save that, and then we can look at that particular, oops. So here's the data file on the server, and then you can see here's basically the database. It's got the breed and the disposition is present, as well as the fur length.
So this is actually dynamically updated kind of file, right? When you press some enter, it is updated in the.
Right. Anytime I save a change, so now if I do anything here, it's going to say this is changed on disk. So here I can reload it, and then it should show. I didn't actually reload it. There you can see it's gotten the updated value. Yeah, so that really all of the data for a particular simulation is always within this data file, which makes it actually easy to back up. If you want to back up all of your simulations nightly, you don't have to back up all of the report information. You really just have to back up one data file per simulation.
So that's probably the thing, because we were actually discussing with our sysadmin at BNL, and he asked actually what to back up. And we, with Maxim, we actually didn't have a clear flow, so we ended up backing up entire Sirepo directory.
Right, and the disadvantage of backing up, so on production, for example, we do actually back up everything because we want to preserve the reports. But in reality, the reports can always just be regenerated, and you don't really want gigabytes of report data in your backups. So if you can be specific about it, you can really just back up.
Yeah, that's interesting information.
The specific, so the run directory has everything. Got all of these files, but the important ones really are just these Sirepo data files. Actually, that's not entirely true. Actually, if a user has uploaded, let's say a user uploaded an undulator file, they would have that file would need to be backed up as well, and that's within. Let's go into this user. It's within the lib directory for each user. So yeah, the safest bet is back up everything, but yeah, you can definitely be very specific. Or you can definitely just say, I want to back up everything, but never a report. And that's possible by, let's look at myapp, and then this simulation, meaning I would back up anything in this directory, but never go down into something named report. If you've got configurable backups. Okay, so let's see. I showed how to add a field. Okay, yeah, Boaz had the question of how do I hook it up so that if I change this, something else happens. So, for example, I'm going to change defaults based on something I enter. And then that's within the business logic client side, which is in the package data static JS, and then in this case the hello world is called myapp. And if we look here, there really is actually no business logic. There's some code here saying there's footer things, and there's some code here saying here's how I want this particular heading to lay out. But in general, we don't change these much at all. Let's say I've got a controller for this page. All Angular apps may have a controller associated with a particular page. So here I'm on the source page, and then in my myapp schema at the top, we had this source route, and then this specific thing saying this is the name of my JavaScript component and it's named source. It's JavaScript. I've got this myapp source controller. It really could have any name. You could call it source controller. That would be fine too. And then this is where business logic goes. And there's a couple tricky things. One is you don't really want to execute your business logic until the page is loaded. So I'm going to copy a bit of code from SRW. And then this says when the page is ready to go. And in this case, I'm just going to just show a quick message. I'll bring up my web console. So here's my web console. When I reload this page, I get an error because I didn't include app state. Okay. Okay, so there I've loaded the page and output the message. And the question is, what does page loading mean? If I did something here, controller, sorry. So here you can see I've got two outputs. It says controller is starting and page is loaded. If I come out here and come in again, I'll see those same messages. Controller is starting, page is loaded. The problem is in these types of application, you may not actually have gotten your data yet from your server. This app state when model is loaded ensures that I know my model is available. And it's available actually. My model was called dog, and I can actually look at it here. And here I can just also print out what the of it is when I first come into the page. So here I'm going to reload the page, and I didn't correctly, I believe. Let's see. Okay, so it's actually app state models, and then dog is the name of the model. But you notice when I first came into it, I got an undefined value here. Well, that's because I didn't name it correctly. Let's give it the right name. And it's an object, but it's empty. So you see, I came into the page, there's an app state models, but it's empty. And that's because the server or the client actually hasn't requested the data yet. Mm-hmm. And so you can't actually do anything dependent on the data until you actually know it's available. And that's a long-winded way of saying, why did I put when models loaded here?
Can you trigger the end of loading or something somehow to sequence this?
The trigger actually is this. So it is, this is actually giving it a callback function. So that
when loaded. Okay.
When it's loaded, it invokes all of its callbacks.
Okay, so, got it.
That's because JavaScript's very asynchronous. You actually have to do a lot of things with callbacks because you may not have the data or it may not be ready to go. But in this case, I know I've got my model and I'm on this particular page and I want to do something, say when the disposition changes, I want to trigger some action. And the way I do that is within a Sirepo. Again, I have to actually look at it. Watch. Get another Angular, and I'm going to say okay, so what this will do, maybe first time I run it, or maybe after I fix any bugs I have in it, is this, the UI says, I'm interested in what Angular calls watching. I'm watching a field, waiting for it to change. And in this case, I named the field dog disposition. I'm only interested in that particular field. And if anything happens to it, call this callback function, which for now is just printing out a message. So we'll try running this. I'll get rid of this particular comment for now. And so I reload it. And now I change this. And then you see in my thing, it's changed to friendly, or it's changed to angry. And now at this point, I could do something in the UI. So let's just do something simple. We'll show or hide a particular field depending on
make the fur length a little bit longer. If it's
well, I think I might just hide the fur length field just as a simple example. So we'll say another Sirepo class called panel state. And not to get too much into it, but app state really in Sirepo is a Sirepo construct which handles all the model data, and you can ask app state to save or do all sorts of things. Most of it does for you already. There's another module called panel state, which is more directed towards handling individual UI elements. So I could say, ask the panel state to hide this. So when I hide this page, it's actually using a panel state. Or if I hide a field, I'm going to ask panel state to do it. So here I can say, and I'm again going to look for an example from SRW. I'm going to say panel state show field dog disposition, and we're going to say if it's not angry, models dog disposition angry. What this says is show this field on the dog model named this if this particular Boolean is satisfied. So let's just try it out. So it's submissive. I hit friendly, it's still there. I hit angry, and I hit the wrong field. So I hit disposition field when I meant to hide the fur length. So let's do that again. So here I come to friendly, it's still there. Submissive, it's there. Angry, it disappears. And so that's a very common thing within the UI is arranging things based on what the current values are. Now, this actually has a bug in it in the sense that if I say angry and I save changes, everything is fine. But if I come back to this page, fur length is still there, even though it's angry. So what I didn't handle is the case when I first come into the page. And then that would be handled by, say, creating a function, dog disposition. I can't spell that word. Here I've got a JavaScript function. I'm going to move this to. And I'm going to call it here. But I'm also going to call it when I first come into the page. This is saying, when I come into the page, show or hide the dog disposition.
Yeah, initialize.
So hide it if it changes. So now if I refresh, it's hidden when I first come into the page, or will show up, and it should still appear. And I got a server error. It's okay in this case, actually, because it was trying to cancel a simulation, some part that I didn't. I actually exited out while it was simulating, and we didn't have a correct hook in there to cancel this particular hello world simulation. And actually, I can. This is actually this is just an interesting debugging problem. So what happens if I get a server error? So let's do this quick. So this one was reproduced actually by saying save changes and then exiting out before the report completed, which caused the client to say cancel the simulation. We're no longer interested in it. So I'm going to hit save changes, exit out. And then I got a server error. And then here I'm looking at the stack trace. It was coming in with a call to run cancel. It's basically saying forget it. And then here it came into API run cancel and tried to call remove last frame. I happen to know that that's implemented in most apps. For example, if we would look at SRW, it doesn't do anything, which is really the normal behavior. Other applications might have to clean up a bunch of things, or remove a file that was partially written, for example. And I'm just going to add that. Actually, I'll get to this in a bit. Actually, is everybody okay on time? Maybe I'll go 10 more minutes?
Yes, that's absolutely fine with me. Yeah.
Okay. Okay, so I'll go 10 more minutes and hopefully I'll get into this. But basically, I'm showing when you get a server error, and this one wasn't actually particularly easy to go into because you actually don't know what the module was, but I happen to know that I just recognized the error, I guess. But if I reload this, the web server automatically reloads when a file changes as well. If I come into my last simulation and then exit out quickly, I didn't get a server error, and that's basically because it got into that particular code to ask it to clean it up, and then it didn't do anything. So that was another digression. Okay, so back to the JavaScript. Okay, so here we go. So that was really just a simple example of how to respond to a field and how to get it to show up correctly when I come in. And if we would look at SRW, we've got lots and lots of this kind of thing. So let's look at an example in SRW. So here we are in a controller, and it's a very big controller called SRW source controller. And that's the controller that shows on the source tab. And it's got lots and lots of hooks. And let's look at a simple one here, maybe, if I can find a simple one. Watch model fields. So here it's watching a lot of fields on the electron beam. And then when it executes, it goes to process beam parameters. And let's just look. Oh, I see. So process beam parameters actually goes to the server. So this is interesting in a sense that you see what happens here. So if I come in here and I edit the beam and see what fields, horizontal emittance, for example, and I change the horizontal emittance, and actually let me do a couple things. I change the emittance slightly and hit Save Changes. Actually did it immediately. So the moment I start typing here, it's actually doing something. And not exactly sure what it's doing. It's going to the server and saying process beam parameters, coming back and setting the size and looks like the drift position. And I'm not exactly sure why it does this, but it's business logic. So here you go. RMS size. Oh, I see. So that's probably keeping the moments in line with the twist parameters. So if I change the twist parameter here, it will have gone to the server, recalculated the values, and come back and hopefully change something here. I don't exactly know what changes with
the emittance should change if you change the sigma.
If I change
the RMS beam size.
So if I change this to 10, for example, see, so it did. It changed the RMS size. Or if I change it to 2, it's changed to 63. So that's an example, and this is a really complicated example because not only could the client's responding to the event, the client actually has to ask the server to do a calculation. So we use the SRW library to actually compute the changes between the twists and the moments. So that's a really complicated example. I don't really like that example. Here's a different example. So here I'm on the drift calculation and I hit manual. Then I can edit this field. If I hit automatic, it disables it. That's all within the client side. So we can look at that. Let's see, enable field. And it might take me a moment because this happens a lot. Here we go. So here in process beam fields, it'll come to this particular thing and says, enable the electron beam position model field drift and enable it if is auto drift is not selected. So automatic, it's disabled, manual, it's enabled. And so that's just an example. SRW has lots and lots of business logic. Myapp has business logic we just added just now. And I may check this into the Myapp just to sort of show another example. But if you're interested in other apps, a really good resource is actually all the other apps we have. So if you've used one of our apps and you're interested in how it works, you can just go look in its code. For example, we have a program called JSpec, which does a lot of things. Let's look at it quickly.
We are interested in SRW.
I'm just saying you can get
If you can just say where these files are located on the server, because we had a difficulty to locate them. Maybe you already discussed this.
Sure. Yeah, I'll back up to that. So, okay, so let's say what happens when I come in here and I change this and hit save. What is really actually executing and where is it executing? And then I actually have an image for that. Okay, so this is a diagram of what happens on the server side. So again, the Sirepo data is basically our database. There's an application-specific server code in template SRW. and it refers to the schema. It refers to a Jinja file, and it creates executable Python as a result. And then another process will then start it, and then this particular thing will then interpret the data to get it back to the client.
And where this files allocated on the disk of the...
Sure. So let's look at the source tree. So here we were looking at all the client things. So this is the Sirepo root. This is the Python directory here. So into Sirepo, into Sirepo. And then template is where all the server logic of the apps. So here there's one for myapp, and here's the one for SRW. And so I want to look first at myapp just so we understand what the very basic execution flow is. Look at myapp. It's got an interface, a public interface of only a couple methods. The most important one is, I guess, write parameters, and that's coming into the program to say, write the data files. And in this case, it's generating some code and writing it to the parameters.py file. And now, if we look at SRW, it's going to be a lot more complicated, but it should have, here's the write parameters method. And again, it's very similar. It's saying, generate the parameters and write them to this file. That's within the run directory itself. Now and so this file is in Sirepo template SRW. And so code to generate SRW is pretty complicated, but you can see, let's see how long this is.
I just saw some funny place I wanted to change when the range for trajectory was not always correctly swapping up. You just showed it.
Oh, good.
So, I mean, that's a very interesting knowledge.
Yeah. So this really is the guts of it. So it's going to come in here and do quite a bit of things. It's also relying on Jinja templates to generate the code. So a lot of this code here is just setting up the models. Then it validates them to make sure that the data looks okay. Looks like it sets a couple more fields. And then at the bottom, it actually does the Jinja. Now, let me see if there's actually a couple different places where
Jinja gives you all of the default, is the template to create all the default values?
Exactly. So Jinja is used by Python programs to generate templated code. So let's look at the Jinja for this. And this exists. So if I'm going to come out here, the Jinja files are in package data, and then static. No, not static. Package data, and then template, and then SRW. And then here, we've got quite a few things. We've got input files and various things, but also the important thing is that the Jinja files are here. So let's look at them once. Package data, template, SRW, and then parameters. And so this should look very familiar to the generated SRW code. You can see it's really very much similar to what you see when you say view source, except that it's got placeholders for all of the parameters.
Yeah, it looks like server pages, active server pages or something like HTML with holes.
Exactly. I think they're all kind of similar, that you can have commands with it. So like if the source type is not Gaussian, it does this particular part, and then the escape characters are these double curlies. Mm-hmm. That's that part. The line code is actually generated as well, and it's actually not straightforward. But if you need to change a beamline element, there's beamline optics. I'm not sure if this is the right file. Yeah, so this is something you can kind of see. So you can kind of see it comes into this code generator. It says, if I'm looking at a fiber beamline element, this is the code I generate. And so here you can see it's setting all the fields and the propagation parameters. And so let's say we added a field to grading. We would come into this Jinja file and potentially add, oops, there we go.
This is on the level when dialogues are generated, right, for the input of values? Or it's...
Right, no, this is really just the code generation that gets executed on the server.
Ah, okay, got it, yes. Mm-hmm.
Yeah, it's all the rest of the dialogues is all within the JavaScript, not within the...
Yes, sure.
So when you add a new element in the interface, it's gonna be using this this code.
Correct. So let me back out for a second and say, let's say I was in the SRW schema, and say you added a totally new beamline item, you would add a model for it. Let's just say in this case, well, actually zone plating was one I added recently. So here I've got a zone plate model. It's got a lot of attributes based on it. And then I would also add a zone plate view, which says this is the way it's arranged with a geometry tab and a material tab, and it's got various items in it. So now I've got the view for it. And then I would have to add it to the generated, this is the actual code that gets generated for a zone plate, and it's just taking these particular values.
Yeah, so whenever you add a new element in SRW, you need to take care of both of these two parts.
Right, yep, you always client and server. And hopefully there's not too much on the server. So like if I would look at the regular SRW server, I wouldn't see zone plate in here too much. Actually, I don't see zone plate at all. The mapping here saying I always name it this in the generated code, but that's actually the only place zone is actually mentioned within the actual thing. So it's really just in the Jinja template and in the schema for the application. So that's a good case. Like electron beam, you can see there's actually quite a bit of business logic in here doing various things. So it's not always, super easy.
Yeah.
But zone plate was easy.
Where are the propagation parameters set? For example, for zone plate, I didn't see where you set the propagation parameters.
So let's look in the UI first. So let's go to CW. Actually, I got it open here. So let's just create a quick one. Okay, so here's the propagation parameters. And I'm going to just modify it slightly just so we have something interesting to look at. And now let's look at the propagations for this particular, let's look at the data file for that so I can show you where the propagation parameters actually exist. Okay, so I looked up that particular data file, 1cdc, for example, in the directory. I'm going to open it, look for propagation. All right, and this is actually the way it's stored internally. And the way it's stored is this is the ID of the element. So here I've got an element 2 and 3. Element 2 corresponds to probably the aperture. Yeah. So here's the aperture. The beamline, it's got an ID of 2. And then this is the way propagation parameters are stored.
But how did those get set from the Jinja? It looked like in the Jinja file that you had a number of default parameters, and I was wondering what the default.
Let's look. So we'll look at the Python source first. Okay, so here's the aperture planar, and here it generates the source, and then here it adds it. And then the question is, where did that come from? Line optics, and let's look at aperture. And so here's the code it generates, and then here you can see.
So there's the PP.
Yep, 2 lines. So first to append it to the elements, and then to append it to propagation. And elsewhere, it's generated the propagation parameter. There's another Jinja file that actually does all of this code. So let's look here quick. Let me get it in Python. Aperture. So recently we made it so here you see the beamline optics have their own section within the thing, and then that's controlled from the beamline parameters Jinja file. So here's values for an aperture, and further down the list it generates it for the propagation parameters. So here's the propagation parameter list, and then this is the Jinja, and again it's sort of compact.
I see. So it's getting it from the other file.
Right. So really, this srw.py file in generate parameters, it sets up this v value, which is really all of the values that are going to be used in the Jinja template. So there's a tabulated undulator gap, which it looks like it's converting units, and so on. So everything's within there, including propagation parameters. And I'm not exactly sure where that's. Somewhere within there, it creates it, calls this Jinja template.
This file that you are displaying now, it's a static. It's never changed, right?
Right.
It is by this Jinja, right?
Right. This Jinja file really is just a static file that gets read in, and then all the variables in it gets replaced. And it just creates a string, which we then write to disk and then execute. So all the Jinja really is just formatting to end up with this execution file at the end of the day. So there's a special Jinja file to do the optics, special Jinja file to do the inline parameters, and a special Jinja file to do the optic and propagation values. All right. Well, I think I'm done.
Yeah, that's very comprehensive.
Yeah.
I guess. Well, I personally have questions, but I mean that's for next time. I guess that's for
okay.
Sure.
Yeah. And so we'll hopefully get this recording put out, and it can be rewatched, and we can do questions next week or whenever is convenient. So I guess I'll sign out. Bye bye, everyone.
Yeah.
Okay.
Thank you. Bye bye.